Assalamualaikum, we are from Group 9. We will presenting about our project which is GD&T Drawing Application on Shaft. This is the group information of this group. My name is Intan Nur Shazanani and my group member is Nur Amrina, Siti Hasmah, Nur Ain Balkis, Nurul Izanti and Haras Nuruddin. Siti Hasmah and I will present the introduction. The objective for this project is to demonstrate the ability of students to identify geometric dimensioning and tolerance with respect to actual function and relationship of part feature. Second, to understand more about GD&T chapter and apply it in real life. Third, to test student understanding on GD&T, and the last one, to calculate the measurement analysis of shaft. The scope for our project covers the following discipline of applied metrology, which is GD&T application. In this project, we are only required to use GD&T application. Next, the importance of GD&T drawing application critical dimension. The first one, ensuring dimensional and tolerance requirement. By explicitly stating all design requirements, a true rough GD&T process guarantees accurate fulfillment of all dimensional and tolerance specifications. Second, improve reliability and quality. With all teams using a consistent language, GD&T avoids the misinterpretation that often occurs with crowded and confusing drawing notes, and instead allow for the desired dimensional and functional specification to be achieved. The third one, offering uniformity and convenience. As a single, consistent language, GD&T reduces guesswork and interpretation while ensuring consistent geometries across design and manufacturing. The last one, increase flexibility. As a general rule of thumb, designers should keep tolerance as large as possible while maintaining the desired functionality of the part. Manufacturer may think using GD&T result in tighter tolerance. However, GD&T actually result more manufacturing flexibility and large tolerance, especially for intricate or complex design.
Next, I will be presenting about the literature review of geometric dimensioning and tolerancing GD&T. GD&T is a system for defining and communicating engineering tolerances and relationships. It uses a symbolic language on engineering drawings and computer-generated three-dimensional solid models that explicitly describe nominal geometry and its allowable variation. It will be benefits of GD&T. It is a standardized and international system. It also allows cylindrical tolerance zones. It is more flexible particularly for complex shapes. The datums are clearly defined. It also based on the fit and the function of a part or assembly. It also allows for more tolerance. Geometric tolerance. Geometric tolerance is a system that allows tolerances to be applied to features rather than dimensions on engineering drawings. It also allows different aspects of form, orientation, and location to be toleranced independently on each other. This also allows tolerances to reflect the functions and relationship that the designer intends. The advantages include productivity can be improved without relaxing tolerance requirements, and tolerance zones can often be enlarged. Here is a list of the most common symbols that we will be using when writing and reading GD&T.
This part will demonstrate the procedure of specific method with the aid of pictures on how to generate a good GD&T drawing. Poorly stated specs can have long-term consequences. We don't want the drawings to be caught in that trap. We want our part drawings to convey our design purpose in a clear and succinct manner. Geometric dimensioning and tolerancing tools provide a simple language for translating functional requirements into design intent. There are 5 steps. The first one is to identify the functional features. Begin GD&T implementation by specifying the functional aspects that are crucial to device performance. A standard component may have dozens, if not hundreds, of dimensional callouts. However, only a few of those dimensions will have an impact on the part's intended function. Interfacing assembly elements on the bottom and top halves of the molded cassette, such as a mating boss and hole, have an effect on the part's operation. The second step is choosing the controls. Choose the control that best reflects the functional goal. Take care not to use a control that needlessly complicates the functionality validation. Third step is providing the maximum permissible deviation from the nominal value. We should be aware of our product's upper and lower specification limitations. Tolerances convey the part's manufacturing restrictions. This is the first and most evident advantage of employing tolerances. When we add a tolerance to a dimension in our design, we are specifying the goal dimensions as well as the upper and lower bounds of that dimension. These constraints must be met by the produced part. When the part is inspected, the dimensions and tolerances provide the criterion for determining whether or not the item is acceptable. Besides, tolerances guarantee that pieces may be assembled together. This is a tolerance most essential rule. First step is defining the datum references. We need to know which external feature to refer to. This is referred to as our datum feature. Some GD&T controls such as form control do not permit the usage of a datum in an assessment and instead include a clearly specified call-out that only includes the control feature and tolerance. Other control parameters such as orientation and position will almost certainly necessitate the use of a datum in order to be evaluated. Last step is designing the datum alignments, a key feature denoted by one or more datum references at the conclusion of a feature control frame is used to assess the specific control characteristic. There will be 3 datum features in a properly restricted datum reference frame. These datum elements form a potential intersection. This intersection establishes a point of origin as well as an alignment axis. A completely constrained datum alignment in best practice will constrain all 6 degrees of freedom concerning a component. Milled steel is the material used for standard shaft. When extreme strength is required, alloy steels such as nickel, nickel chromium or chromium vanadium steel are utilized. Hot rolling is commonly used to make shafts which are then called drawn or turned and ground to size. Shafts use different materials on different applications. To know which material is the best, some tests may be done. We can find the safety factor and its maximum stress by doing the simulation of the shaft in SolidWorks. When finding the materials for the shaft, it shall have these properties which are high strength, good machinability and low notch sensitivity factor. For example, there are 2 types of cold shafts which are steel and graphite. Steel shafts are much heavier, more durable and less expensive in general, whereas graphite shafts are much lighter, less durable and more expensive.
Assalamualaikum warahmatullahi wabarakatuh and good day to Dr. Salwa binti Mahmud who is viewing our video presentation. I am Nur Amrina binti Ruslan, matrix number CN190033, will presenting the instrument, handling and safety precaution, also observation of GD&T application on shaft. There are measuring instruments and machines to measure features for GD&T measurement. Instruments and machines that measure geometric characteristics can be categorized as follows. First, the GD&T measurement instrument, surface plate, a plane that supports the datum plane with the highest precision, made of either stone or cast iron. Second, the V-block. It acts as support for circular or spherical measurement targets and made of steel or cast iron. Third is the height gauge. Can be accurately read with the scale or digital meter. The base of the scale and the surface gauge being integrated can measure parallelism, flatness and straightness. Lastly is the dial gauge. It can measure and compass parallelism and height. It can also indicate changes in the target's warpage or eccentricity in detail. Next is the GD&T measurement machine. First, roundness measuring instrument. It can measure straightness, roundness, cylindricity, parallelism, perpendicularity, coaxiality, circular runout, and total runout. It equipped with a rotary table and use a stylus that touches targets to measure various geometrical characteristics. Next is the Coordinate Measuring Machine, CMM. It can precisely measure angles, positional relationships between elements, profile, and geometrical deviations in addition to lengths of complex stereoscopic objects, and detects three-dimensional XYZ coordinates when the operator specifies the target's measurement point. For the handling and safety precaution of the GD&T application, first, clarity of a drawing is the most important, even more so than its accuracy and completeness. Next, always design for the loosest feasible tolerance to keep costs down. Tolerance functional features and their interrelations first, then move on to the rest of the part. Next, dimensions and tolerances are valid at 20 degrees Celsius or 101.3 kilopascal unless stated otherwise. Lastly, whenever possible, leave GD&T work to the manufacturing experts and do not describe manufacturing processes in the engineering drawing. For the observation, first, GD&T application establishes a coordinate system for inspection and manufacturing. Then, it provides a precise and consistent method for communicating design intent. It also reduces the need to explain complex requirements, and GD&T application identifies critical to function features. Lastly, it facilitates and simplifies gauging requirements, also tolerance analysis.
Hello and Assalamualaikum. My name is Haras Nurdin bin Ghazali with number matrix CN190084, and today I would like to present about our discussion. So the purpose of the discussion is to interpret and describe the significance of findings in light of what was already known about the research problem being investigated, and to explain any new understandings or insights that emerge as a result of our studied problem. So geometric dimensioning and tolerancing GD&T as specified by ASME and ISO standards has a number of advantages for producing clear, full, and unambiguous product specifications. Users may demonstrate design requirements and tolerances in ways not possible with just plus and minus tolerances according to standards like ASME Y14.5M-1994 dimensioning and tolerancing. Considering the following scenario. So there's 5 scenarios. The first one is functional gauges can be used to ensure that components will fit into the assembly even if the mating circumstances are otherwise. Cylindrical tolerance zones can be given to cylindrical feature in feature control frames. Tolerance stack-up analysis become easier and more trustworthy as a result of this, with cylindrical gauge pins and gauge holes for orientation and position controls. This sort of control makes it feasible to measure that created features. Geometric tolerances may be measured quickly and effectively in this manner. The second one, static and floating tolerances for fastener assembly, such as position tolerances, may be computed quickly using simple formulae. Their tolerances are determined by manufacturing capabilities and economic concerns, and they may be checked using simple formulas to ensure that all components accepted by inspection will fit together. Furthermore, tolerances projected out of threaded holes to resemble screws increase the likelihood of pieces assembling without binding. And the third one, for orientation and position, specified datums serve as measurement beginnings. They serve as a coordinate systems, allowing everyone to put up the manufactured pieces in the same way. This enables for repeatable, functional, and representative inspection data to be obtained. And the fourth one, additional tolerances based on produced feature sizes can be allowed though the use of the maximum and least material condition symbols without the loss of quality or functionality. When combined with the fact that cylindrical tolerance zones provide about 57% more manufacturing tolerances than the equivalent square plus and minus tolerance zone, design engineers who use geometric dimensioning and tolerancing will consistently design highly functional parts at minimum manufacturing cost. And last but not least, the fifth one, tolerances can be applied to features that share a similar axis or center plane to limit how much they can deviate from one another. And that's all for me. I will proceed to our next presenter. Thank you.
As for the conclusion, GD&T used as a point of reference in order to easily and effectively manufacture products that meet the fit, form, and function requirements of the part. All proportion must be tolerable. The tolerance for variations must be set for every features on every manufactured part. This project may demonstrate the ability of students to identify GD&T with respect to actual function and relationships of part features. From this project also, students understand more about GD&T chapter and apply it in real life. Students also learn on how to calculate the measurement analysis of GD&T while doing this project. For the recommendation of GD&T, first is prerequisite knowledge. GD&T is an advanced concept that assumes the user understands all print reading rules, conventions, symbols, and terminology. The complexity and technical intricacies of GD&T are beyond the comprehensions of users who have not mastered basic drawing concepts. Second is language fluency. As a language, there are levels of fluency to achieve. The dynamics and relationship between the parts features expressed on a print will not be fully understood until the user is fully fluent in the language of GD&T. Last one is 2D versus 3D perspective. A user must be able to mentally grasp the link between the features of a part, in addition to the needed knowledge and language competence. Non-print readers and those unfamiliar with print reading will find GD&T difficult to navigate and difficult to grasp.